we are not able to see your screen. I think you are
Yeah,
not.
I'm not able to share the screen. I don't know what is. I'm clicking on share the screen. Some issue. Okay. So we'll look at theory first and then we will go ahead with everything else. So alright guys, so OMP is, as I said, is a core protocol which we need to know because this is what is taking care of the overlay, right? So we'll basically discuss that and then we'll do a lab. We'll basically verify yesterday's lab about what we are reading here. So what is OMP? Cisco SD-WAN OMP is the control plane protocol that runs between the WAN edge devices and vSmart controllers. Okay, and also as a full mesh between the controllers. So OMP protocol has nothing to do with vManage or vBond because they do not run OMP. It is purely a control plane protocol which is related to vEdges and vSmart controller. Right, so between WAN edge and the controllers, vSmart controllers, right? So the Cisco SD-WAN applies the principle of software-defined networking, which separates the control and data plane of the networks. This means the control plane information is never exchanged between WAN routers, right? What is the meaning of that? That means all control information is with the vSmart, and all the data plane work is done by the vEdges. vEdges only send and receive information through vSmart controller as shown in this, which is basically related to the control plane. For data plane, they don't have to do anything with the vSmart. They will never consult vSmart. vSmart will not come into the traffic path, data path, although they will consult this vSmart because he is responsible for telling who can talk to whom. But actual data traffic never passes through the vSmart controller. Okay, so where is the OMP protocol? Always between vEdge to vSmart and vSmart to, if you have redundant vSmarts, between them. All vEdges are going to connect to only one vSmart at one time. Okay, and these vSmart for the backup will also have another vSmart connected to him. If he fails, the other one takes over. But these vEdges are essentially going to connect to, every vEdge has to be connected only to one vSmart. Guys, any doubt, any confusion up to here? Very, very important things we have discussed here. Very important things. This forms the base of everything. So it is the OMP protocol, which is a BGP-like protocol. It has three type of routes, which we are going to see later. And this guy acts as a route reflector, right? So that there is no route looping. So all vEdges will form neighborship to him and will never form OMP neighborship to each other. When you do show OMP peer, what is that you are going to see? Only vSmart IP. Even if you have 100 devices in the network, each device will only see OMP peer as vSmart. Take it as a BGP. It is very close to the BGP protocol. In BGP protocol, what happens? You have, one is a network table, the other is the peer table, right? The neighbor table. And then you have data plane table, right? So here also almost similar kind of stuff happens. So the network table is what is also your prefix table or the data table, right? Based on the network table is what is the data table is created. And then you have neighbor table. So here also you have OMP neighbor table, OMP real routes, which are the service VPN routes, private routes, and then these TLOC information, which is like a next hop information, or in BGP you have the next hop terminology. So what is OMP peering? So here it is. The Cisco vSmart role in the network is very similar to the BGP route reflector. The controller takes all the routing and topology information received from every WAN edge device and calculates the best path based on the configured policies, and then re-advertises the results to all other WAN edge routers. Right? So V edges are not responsible for calculating any best path to each other. vSmart is responsible for that. Why? Because it is SDN, a centralized mechanism of controlling everything. Right? A centralized mechanism. What was happening in the distributed mechanism? Each router used to calculate his own routing table, etc. Right? Here they are just given the best path that vSmart calculates the distance and everything, preferences and everything else from them, and tells the other guy how to reach there. So what is OMP peering then? OMP is enabled by default on all Cisco WAN edge devices. When vEdge go through the zero touch provisioning process, they learn about the address of all vSmart controllers and automatically initiate secure tunnels to them. By default, all these connections are authenticated, encrypted via DTLS protocol, which I told you is nothing but SSL protocol, right? Depending on the number of available transport, each vEdge router will try to establish a secure control connection via every TLOC, right? So here in the diagram, we'll look at it. So each of these vEdges are going to use DTLS to form the basic secure connection, and after that they will form OMP connection. So DTLS is underlay, OMP is overlay. Each vEdge keeps one permanent connection to the vSmart controller via each available transport. So no matter how many transport you have, you need to be connected to at least one vSmart, right? With all your links, whatever links you have. So this vSmart has 2 TLOCs with this guy. Okay, so here we can see that show control connections on vEdge 1. These are control connections, so no DTLS, sorry, no OMP is being discussed here, right? But if you check OMP peer, you will have all vEdges are going to have one vSmart, nothing else. They will not have any other information about any other vEdge. They will just form like a route reflector in BGP. You do not directly form neighborship to avoid looping. You all choose one route reflector and have neighborship with him, and he will decide what to send to whom. So each vEdge is going to have only one neighborship, and that is going to be with the vSmart. Right? So these are the protocols being used. First you have a DTLS or TLS connection. On the top of it you need to have netconf for configuration and OMP, etc., different protocols for whatever communication that you want to establish with vEdge and vSmart, or different from vSmart controller to different vEdges. Netconf is a configuration protocol, you are aware of that, right? DTLS and this TLS is basically what is the certificate authority kind of thing. They use certificates to authenticate the devices, and OMP is for the routing in the SD-WAN solution. So it is purely a routing protocol, you can say that. So here you see that peering between the vSmart, they need to have full mesh between vSmart controller, but vEdge will only have one connection to vSmart. OMP routes, so there are, what kind of routes do we have? As you know, we'll try to compare it to the BGP to make it easy. The first routes are V routes, also called OMP routes or just routes. Are prefixes learned from the local LAN. What are those routes? Yesterday we discussed about service VPNs. What are service VPNs? The private VPNs, right? Which is anything which is not 0 and not 512, that is a service VPN. and that has to be the one that you want to transport over IPsec protocol, right? The one that you want to transport over IPsec protocol. So these routes are also known as V routes. Okay, V routes, which are in BGP. What are those routes? Basically your network prefix that you advertise with the network command. Correct? So here it is basically those routes. These routes can be locally connected prefix, or one can be learned from dynamic routing protocol like OSPF and BGP, and now EIGRP is also supported in the newer versions. Once the VH device learns these prefixes, it redistributes them to OMP as V routes so that they can be carried across the overlay fabric. So that is first type of route, which is basically the vSmart controller responsibility is to pick up the routes from one side, do its algorithm of whatever preference, weight and other things are which are there, almost like BGP kind of thing, and redistribute that information to the other side. The routes can be connected, could be static, could be locally directly connected, could be dynamic routing protocols, whatever routes, it doesn't differentiate between them. Okay, although there is an order of operation and a order of preference also, which we'll discuss. The next route is TLOC route advertise transport locators. Right? We discussed transport locators 2-3 times. What are transport locators? The next hops, essentially, right? The next hop on each device. So the exit interfaces or the WAN interfaces, but TLOC has a little more information about them, which is along with the public and private IP address of them, color, TLOC preference, site ID, weight, and if you have encryption keys from DTLS, etc., that will be basically shared with the other side. What are these? These are, you can call it BGP Neighbor Table. Right? These are the network command that you generally give, and this is the BGP neighbor command. You have neighborship details of all the neighbors, right? So that is the difference between V routes and TLOC routes. Now the next thing that comes is service routes. What are service routes? These are basically very new concept to most of the people. These are add-on routes, you can say that, or embedded network services. Let's say in your network you have a firewall or intrusion prevention system that are connected to the VH local LAN, right, the private side. And let me give you one example here. Because these routes are little new concept. So let's say you have these V edges, and this is your data center side. So these are your data center side, and these are your branch offices, all connected to whatever internet. They are all in different cities or different parts of the world. And you decide that you do not want this traffic on these V edges to pass through from the internet itself. You want it to pass through. There is a firewall here in the network, and that is where the internet is. So you want these people to pass through the firewall securely, and the world should also come to these sites using securely. Rather than investing into firewall on each branch, what you can do is you can have in the head office or in the data center a huge firewall, and let all these devices securely connect to the world, and the world securely connecting to these people. So this network is advertised by TLOC routes, V routes. These information neighborship is TLOC route, and this service that you are adding, this service can be anything. It could be firewall, it could be IPS, it could be load balancers, F5, etc. Any kind of load balancer. It doesn't matter. Any IP based service, any layer 3 based service can be added here. Okay, and these routes are known as service routes. right? So these are basically your service routes. Guys, any confusion up to here?
Sir, can you show the diagram which you plotted? So where the firewall you discussed?
Yeah, I'll bring it.
Okay. So usually for every site we are keeping the firewall, but in case of for SD-WAN we only need firewall at the DC side, right?
No, that is one of the case possible.
Okay.
It is also, lot of people in corporates, they do not have in all the offices their firewall. They want the traffic to actually pass through this particular thing. In head office they will do investment, or in data center they will do investment. They will put a load balancer, IPS and firewall, etc. And they want all these, rather than putting investment in all hundreds of branches, they will actually put it at the central place one time.
But in our scenario, like where which project I support, we have a firewall for every site.
Okay, you have a firewall for every site. So that
Yes.
should be basically here
Yes. Yes.
for,
Yes.
for your routers.
Yes.
Okay.
That is a normal architecture. But you said in case of SD-WAN, we need to keep the if somebody who's external needs to communicate with us, then we need firewall at one which is at DC, right?
No, 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 no. I'm not saying that. I'm saying that I'm talking about service routes. What are service routes? You have a choice to put your firewall locally. There is no problem with that.
Okay.
Yeah, you can use traditional method, which means investment in all the branches, or you can put it in the head office. That is up to you.
What do you mean by service route?
Service routes are these additional services, these services that you are advertising, that we have to advertise these routes. Let me explain that again. So let's say these are private. I'll draw the private subnet so that it becomes more clear. Okay, so by default what happens is, I don't know why this one is not stretching. Okay, so by default what happens is, in IPsec tunnel, these are the routes which are exchanged, right? These routes, these are the private routes we discussed about. These are what? Service VPNs. And these routes are called in OMP, what is they are called? V routes. These private prefixes. Okay, these private prefixes, whatever it is, 172.16 or whatever it is. So these are your V routes. Then the neighborship table, which is TLOCs, next hop information. That is the second type of OMP route called TLOC routes. The third type is, because by default these are only the private routes are sent. What if I need to tell this private subnet here that, guys, you need to pass through, there is a firewall here, your next hop should be this firewall, right? So service routes are optional. If I have a firewall and I want them to advertise it, introduce in my network, what do? I'm going to tell these people that, guys, your next hop is this guy. So who will advertise it? Hub or whatever it is, data center or whatever. He will advertise services, additional services will be added to these people's route, so that their next hop becomes, rather than this, their next hop becomes this.
So in that case, I have small doubt. Like, you,
Yeah.
from data center to on the other branches sites. So if we have the internet connectivity, then how the security concept come in this?
Yeah, so internet is already secure using DTLS, right? When you are connected between three branches, the DTLS, you have a secure communication to each other.
Maybe there is a internet connectivity, right? So internet connectivity, we have some other IC services or SV services. So
Yeah, but you are
that
not going to
connectivity,
the internet, right? You are not going to the internet here. You are going to your head office, and from there you are going through the firewall for that purpose. If you want to go from here itself, then you can have you can either use local firewall on the SD-WAN solution, which is not very enterprise scale, which is a minimum version firewall, or you have to add additional firewall. You have to buy some ASA or FortiGate or Palo Alto or something and put it here, if the company has the budget.
Okay, sir. That point is clear to me. Like I understood that.
Okay. Right. So the point here is to add this add-on service. We have to advertise them as service routes. This is called, the concept is called, adding this service, the concept is called service chaining. Okay, so that is the concept called service chaining. So here it is, you see that a firewall is being added, so you are telling the other people that this, everybody has to pass through this firewall. You have to tell even that so maybe only branch 2 or somebody else, just one other site needs to pass through it, so you add a service policy there, or service chaining there. So generally it's a new concept, as I said. So V routes, how do you see that? Show OMP route, you can see how the route is received, etc. And is it coming, is it directly connected or is it redistributed, etc. And who is the next hop for it? Is it coming from MPLS circuit, and is it using IPsec or GRE tunnel? And if there is a preference set, if there is any kind of tagging done on the route for filtering, and all those things. So going more into the detail of those fields, here it is. What is the origin of the firewall? It is basically, is the route created locally or is it coming from the other side? Who's the TLOC? What is the next hop for that? What is the site ID? Why the site ID is important, we will discuss in a couple of minutes. So we'll see why the site ID is important in TLOC, right? Then preference. You can set the preference, like in BGP you have that wait and preference. Here also you have that option. If you want to filter your routes based on route tags, you can basically do that. It can be matched and acted upon via policy. Origin is important. You have to find out what is the origin of this route. Is it coming from BGP, OSPF, EIGRP, connected, static? Because these routes, the origin also influences the best route selection. Origin metric, what is the metric at the time of the protocol coming to OMP, right? And VPN, what are the service VPNs, etc. Separation, the VRF tables basically. So let's say here we have site 200 and site 100, right? Site 200 and site 100. So when in the TLOC you have something called site ID. The point is why the site ID is important, right? Site ID is important to know that is VH1 and VH2 belongs to the same site or no. If they belong to same sites, what is the default behavior? Private route of these people should be reaching to the private routes of these people if the VPN number is same. That's a default behavior. But if it is in the same site ID, the VH1 routes will not be exchanged, will send to the same site ID neighbor. Okay, the purpose of that is to avoid any kind of looping. My internal route should not go to internet and come back to me telling that you can reach to these routes through internet. Doesn't make any sense. So private routes can go to the other sites, but not to each other via any kind of neighborship. Although there is no neighborship form, you see that there are TLOCs are not formed itself to VH1 to VH2. No TLOCs are formed. They are only forming TLOCs to other sites. How many TLOCs do you have here? For 2 TLOCs, right? How many here? 2 TLOCs. Here also you have, here you have 4 TLOCs, and here also 4 TLOCs. Right, so that is the purpose of site ID, so that you do not form any TLOCs, because by default the nature is to form TLOC with everybody. Right, but if it understands that it is from the same site ID, it will not form any kind of neighborship with any device in my own network, in my own site ID.
So, sir, like, so it means like it will form that neighborship if it is like different, it is from different site ID, right? The TLOC will form then.
Sorry.
Like TLOC will form if it is from different site ID, right?
Yeah, absolutely. TLOC will only form it if it is a different site, not to our own site.
One here, we can see like 2 TLOCs are there, right? 2 form are there.
Yeah, 2 TLOCs, one to this guy, one to this guy. 2 TLOCs, one to this guy, one to this guy. So everybody is connected to 2 neighbors. T1 is connected to 2. T2 is connected to 2. T3 is also connected to these 2. So 2 TLOCs. They are connected to 4 sites, so 4 TLOCs.
So T1 connected to 2 means like T5 and T6, right, sir?
Correct.
Okay. Then from T5 to T1, T2, and T3, T4.
Yeah.
14.
4 TLOCs here, 4 TLOCs here.
And each TLOC having like the remote side, like the 2 and 2, like, yeah, how many is remote side connective?
Correct, correct. Whatever number of sites you have, you will have TLOCs, that many number of TLOCs there. So what is the information a TLOC has? Basically the TLOC private address, which is the private IP address of the WAN interface attached to the WAN transport. TLOC public address, which is the outbound IP. The color, whatever colors you have, we yesterday selected Biz Internet, but you can actually choose these colors, and I have a detailed presentation for colors also. Encapsulation type, right? So the encapsulation type can be IPsec or GRE. To successfully form a data tunnel to other TLOC, both sides must use same encryption type. Preference, site ID, tag, and weight. That's what we have basically seen there also. Then you have service routes. If you are, these are optional. If you have any add-on service that you want to introduce in your network, you can basically add that service. See how powerful is that service chaining, right? You add a firewall into your network virtually and tell all other sites to use that firewall. Imagine that in the physical world, how you had to basically shape the traffic physically, and create different VLANs and put different policies, etc. Here you just introduce the firewall as a very simple IP service, and that next hop will be advertised to everybody. So OMP best path selection. Here is the best path selection. Is it the route is active or is it stale? What is the next hop? TLOC must be reachable. It will prefer locally sourced route as compared to coming from outside. Preferred AD, if you have set up whatever AD, it will choose that. With the lowest AD, what is the meaning of lowest AD? Directly connected is less OSPF than BGP, right? The different ADs are there. So because it knows the origin, it will also calculate that. Route preference, you can set local route preference for OMP routes using OMP route preference. TLOC preference, the OMP route with the highest TLOC preference. Then you have origin, the preferred OMP route with the best origin, and with system IP, otherwise it is the lowest TLOC private IP. So it's basically reaching to the tiebreaker kind of thing. Here is the table which is given there. By default, there are 4 paths, equal cost paths which are there, but you can set the limit to 16 equal cost path also. This is for OMP routes. Okay, so the same thing there. So manipulating the best path is basically either we can create a centralized inbound policy or centralized outbound policy. And we can also create a localized policy also. Let's see if we need to go to this.
This soft copy is uploaded or no?
Yeah, this book is there. That's the reason I showed you there.
Actually, that time we are not able to see the screen, see your screen. So, okay, yeah, no problem.
No, I'll just show you here. No problems. So here it is, the SD-WAN resources. Here, there you see the videos every day, and here you have SD-WAN resources. So once you click on it, it doesn't require any permissions. You can download the interview guide and this book that I'm referring right now.
Okay, thank you.
No problems. So now we will see the lab part of OMP.
Are you showing something or actually?
No, I'm actually, yeah, let me RDP. I'm clicking on it, it's actually not going anywhere. It's like that day. Okay, so let's see if this still works. Show OMP. I'll just say show OMP, and first I'll take routes, or I'll take peers. Okay, I am on the yesterday's device, which is your VH16. Right, everybody can see the screen?
Yes.
Yes, sir, yeah.
Okay, cool. So here you see that show OMP peers. How many peers do I have? Only one peer. Right? But yesterday on the same lab I've shown you, but if let's say show IPsec inbound connections. How many connections I have? 2 sites. Right? I have 2 sites. What is my IP? 22, 22, 22, 22. And what is the remote site? 17.112 and 18.112. So I have 2 IPsec tunnels with 2 different neighbors. But I have only one OMP peering, which is with my vSmart. So I go to vSmart through OMP protocol. I form a neighborship with OMP with my vSmart, and vSmart tells me the devices that I can communicate, the other WAN edges which are available to me for communication, that will be basically told by the vSmart, and then I will form tunnel with them. Right? So it's almost like your BGP route reflector again, that no matter where you want to go in the world, you go to your route reflector, he will provide you information of where, whatever routes he has available. And then you directly communicate to that. Remember that data plane traffic never hits vSmart. He tells you what to do. He's like a manager. He tells you what to do, but he will never do what you have to do. The manager job is to tell people that you do this, you do this, you did this, or you do this together. But manager is not going to do the task for you. He's part of control plane. He's not part of data plane. So here vSmart acts as a manager. He tells these sites who can talk to whom, and he exchanges these routes also between these sites, which is our show OMP route. So I'm learning two routes. Yesterday we saw that I'm learning 171 route and 188.1.0. Yesterday we have seen these routes. We also pinged them. We can also ping them again. Ping 188.1.1.1. Source is my private was, let's check what is our private, show run VPN 17 17. Okay, so let's see that who is my next home. Oh, this is my local route. So ping 188.1.1.1 and source is going to be 171.1.1.1. VPN is going to be 17. Right? I can reach to him. So I have this route learned, and the other thing is that I am advertising is my local route here. Right? So let's see show run OMP. By default, what is the configuration? As it is set that all WAN edges devices in SD-WAN solution will have OMP enabled on them by default. Okay, OMP enabled on them by default. So this is the minimum basic configuration, and if you want to configure few more things, we can just go here and we can see what are the things that we can do. We can advertise whatever is not being advertised. We can choose it's let's say I want OSPF or BGP or something else, right? OSPF internal routes are advertised by default. You don't need to do that. Only external routes, OE2 routes are not advertised, OE1 or OE2 routes. BGP, it's not advertised. You see that what is advertised here. Show run OMP. Sorry. So these are the two type of routes which are from the private side, private network. What will I do? I will advertise these routes to everybody using OMP in the same VPN. If it is the other side is also VPN 17, then only I will advertise. That's a default behavior. You can do route leaking also. That's a separate topic. Right. So here, let's say again we go to OMP and I want to send maximum path, etc. Send path limit maximum 17. What is by default? 4 paths maximum multipathing, right? 4 paths at once are used, but you can set that to 16. You can shut down if you want, and you can basically choose other features also. Let's see, show OMP services, if there is any service advertised. Okay, service side VPN. What is my private service side is VPN 17. What is that? And the peer is local peer. Show OMP. Summary. It will tell you all detailed information about how many packets sent, how many hello sent, during the neighborship, how many basically the control plane, but the OMP packets, what is the amount of packets being exchanged and with whom. Right? VH OMP is between VH to vSmart, never between two V edges. So very limited feature set, because most of it is automatic stuff like spanning tree. Most of the magic happens on its own, and by default, like spanning tree, it is enabled. Okay, I have for 1717, 1818 and 2222. These are the IPsec tunnels that I have. Guys, any doubt, any question up to here?
But OMP is basically, I didn't see we enable anything like related with the OMP. It's automatically enabled, right?
That is correct. That's the reason I showed the show run OMP. It is by default enable. And by default no shut. This is the default configuration. We haven't done a single command of configuration as of now.
Then how we come to know if something wrong with the OMP, or is in any scenario where we have something wrong with the OMP?
You check show OMP peer. If the neighbor
that is with the V Smart, right?
Right, yes.
Nothing with the V edges.
Between V edges, OMP never runs.
It's for control plane only.
Correct. Between them, they will be told you can form IPsec tunnel to each other, and that is the result of the control plane telling them you can form IPsec tunnels for data plane traffic. OMP is purely a management protocol. Its job is to tell who can talk to whom, and further all other communication will happen between the two parties. Let's say your manager tells you the sales department can go to the HR department for anything. Now manager role is gone. He said that these people can talk. So now further all the communication they can start with each other. But because they have the permission from the manager. If the manager says these two people, or two teams should not be talking, in that case they will not talk. So OMP responsibility is like that manager. He decides who can talk, who cannot talk based on his own policies. The first policy in that is everybody who is part of same service VPN can talk to each other, like VPN 17. If their VRF matches, they can talk to each other. If their VRF doesn't match, by default OMP policy is to restrict those sites talking to each other. They will not be able to talk to each other. That's a standard behavior. But then you can create control plane policies, data plane policies to modify anything that we want to modify. Centrally, we can do that. Guys, any doubt, any confusion, anything else?
No, sir. As of now, no.
Okay,